Am I audible to everyone? Any one of you, please respond. Okay, okay. Thank you. Okay. So let us start our today's session. That is continuation of Google file system, which we have discussed in the previous class, and we'll finish it, and then we'll move to the discussion of Hadoop distributed file system. Now, let me share my screen. Is it visible to everyone? My screen is visible to everyone? Okay. Right. So in the last class, we have started discussing Google file system. Google file system is a proprietary distributed file system designed and developed by Google for its own purpose, right? It will not follow the POSIX notation. It follows its own structure, that is hierarchical directory structures, where it follows the path names to keep the data internally, right? So now, once again, quickly reveal the operations which we can perform with the Google file system, what way it was operated. So these all things, once again, we will reveal. So Google file system consists of two different parts. First part is called as master node, and the second part is a set of chunk servers. Okay, so master node will take care of maintaining the metadata, whereas the chunk servers are maintaining the chunks which are allocated to particular system, and all those things will be processed by those chunk servers, right? So the main design assumption of this GFS is without purchasing highly configured systems, it need to be built up. A new system has to build up with the available commodity hardware, available cheap commodity hardware. So that means whatever the resources that are available, with that they will try to build up a new mechanism. Okay, so what way they constructed this particular mechanism is simply they will make the available resources into clusters. Okay, with the help of those clusters, they will try to distribute the tasks by splitting into parts, and each part will be supplied to the different systems, so that it will be distributed to n systems. Single task can be distributed to n number of systems. Parallelly, n number of systems are working on the same task, and they will produce the results. So in such a way, whatever it may be the size of the file, okay, it will be processed within less amount of time. When you compare the same process with a single processor system, which is highly configured, so there you might have observed the two different problems. One is the processor is highly configured, but the thing, because of the storage constraints, we are unable to accommodate the entire huge file in that particular single system only. So in that case, what happens? You need to store a part of the data, okay, and you need to process it, and then you'll keep those outputs at some place. Again, you are supposed to process the remaining part, like that you have to. So in that case, what happens is the performance, if you're observing the performance, when you compare with the Google file system performance and with the single system performance, there is a lot of difference exists between these two mechanisms. So that is the reason it follows the distributed file system and distributed processing. All right. So once again, we will see the diagram so that we can recollect our yesterday's discussion. Right. So here the master is going to be creates the new chunks by splitting the file into equal blocks. Each block size should be 64 MB, and those blocks will be distributed to various chunk servers. Okay, chunk server physically holds the chunk data, and that whatever the operation that you are going to perform, okay, that will be performed on the block of data itself, and it produces the results. Okay, so in this case, in such a way, the operations are going to be performed on the large files. And another important aspect here itself is master will maintain 3 replicas. That means 3 copies of each chunk block. Okay, and even those 3 blocks will be stored in different places rather than in a single system. They will be stored at different locations, remote locations, right? Why we need to maintain replicas? Yes, so a fundamental assumption while designing this particular system is, yes, definitely there exists a failure of the system. At any given point of time, at any place, definitely there will be a failure of either it may be a chunk server or it may be a master. What we have to do in that case if your system gets failed? So keep it that point in brain. They have developed this mechanism. With this, what happens is, even though if the chunk server 1 gets failed, okay, immediately the master will look for where the secondary copy is available. Okay, immediately it alerts, it passes some control information to the another chunk server where the second replica is available. Okay, so immediately the chunk server 2 will start the execution of that particular block. Okay, in such a way, immediately within no time we are able to restore in the sense we are able to continue our processing without any interruption. Okay, so that is the case why we are maintaining replicas, 3 replicas in the sense 3 Xerox copies, and I mean 1 original and 2 Xerox copies of it. Okay, and then you might have a doubt like, sir, what happens if the master gets failed? Because it is also a system. Okay, what we have to do? Yes, even though in such case also we need to be restore the entire, because of the master failure, the entire system is not going to be corrupted. So that is the reason, even though whether it is master or chunk server, if it is the chunk server gets failed, master will look for the secondary copy of the chunks where it processes. Okay. If the master gets failed, what happens is always the data which the master is going to be maintained will be backed periodically, and those will be stored in shadow. Okay. So whenever if your system gets failed, automatically the backup data will be restored into the system. Okay. And then immediately master will ask all the chunk servers to submit the current status of those chunk server. Current status in the sense, what are the chunks that are available, how many chunks are available, what is the status, like that. All the information related to the chunks are pulled by the master, and each and every chunk server will respond with a message. That is what we are calling it as a heartbeat. Heartbeat is a control information. Just if it listens, if the master is able to listen the heartbeat of a particular chunk server, it assumes that the master assumes that yes, it is in working condition. Okay. If it did not receive the heartbeat of any of the chunk server, any one of the chunk server, what it assumes is, okay, there might be a problem with this chunk server, it is not working. Immediately, whatever the tasks that are assigned to that particular chunk server is going to be redirected to the other chunk server where the secondary copies are available of that same type, same data. Right? Okay. So, in such a way, the master is going to be performed. See, in this way, the Google file system is going to be working. As you need to remember, another the most important point is the Google file system is defined for the purpose of system to system interaction rather than user to system interaction, right? So these are all things which we have discussed in the previous class. This was also discussed. So master operations, what if master reboots? So what it has to do whenever if a master gets failed or it is going to be reboot, what it has to do? Okay. So it replace log from the disk. Okay. Whatever the data that it was previously stored back up to the storage area. Okay. Those all things will be replaced. So what it contains is, what type of data you are going to be recovers the namespace, the directory information. That means whatever the file names and whatever the number of chunks, this all the information will be available in it. So that information will be recovered. In the similar way, recovers files to chunk ID mapping. So as we have discussed in the very beginning of this Google file system, whenever if a client to make a request to the master, master will produce the file name followed by chunk index. Chunk index is the 64-bit number allocated to each chunk during the or while creation of that particular chunk itself. Right? So these all information will be restored, and ask chunk servers which chunk they hold. So as I told you, immediately after restoring the metadata, immediately it conducts a poll. Okay. So what is the purpose of that poll is? It will ask all the chunk servers to respond with the message like what are the chunks that it holds. Okay. And then recover the chunk IDs to chunk server mapping. In that case, what happens is, whatever the message that it was received from the chunk servers is same as the backup data. That means it was already backup the previous data. Okay. When it asks the chunk server to send the information regarding your current status, it verifies. Master will verify whatever the data that exists with that master and the information supplied by the chunk server. These two will be compared. If both of them are similar, then no action will be taken. If whatever the information that is new information, that means latest information will be supplied by the name chunk server, what happens in that case is the latest information is going to be updated with the master itself. So that will happen whenever if the master is going to reboot. Okay. Where to put the chunk server? Okay, this we can. All right. Another important point is master operations, re-replication and rebalancing. Re-replication. Already we have replicated the data. When the situation will be occurred, for creation of re-replication and rebalancing when it will be occurred. Okay, so you just observe the first point. Re-replication occurs when the number of available chunk replicas falls below a user defined limit. Say for example, if you have defined the replica size as 5, assume that replicas, number of replicas are to be maintained is 5. By default it is 3. For your convenience, for your requirement, you made it as 5. Okay, so during the execution of these your particular file, let us assume that 3 chunk servers are failed. Okay, how many copies you are maintaining? 5 copies. So 5 copies are placed at different systems. Okay, let us assume that 3 of those copies are, I mean, the chunk servers are not working properly where these 3 copies are available. What happens in that case? Your replica, what you are expecting, system has to maintain 5 replicas. Out of 5, 3 has corrupted. Then only we have 2. So in that case, what we have to do? We are not sure that the remaining 2 systems are also working properly when it starts working, because they are also systems. There might be a possibility of failure. So we are not sure about it. So that is the reason what we have to do immediately. We need to apply the re-replication process. By using that, we can create another 3 more replicas, and those 3 replicas will be placed at different locations, so that we will maintain 5. Okay, so in that cases, whenever if the replica limit is falls below a user defined limit, so when it will be occurred, as you know, when it will be the replicas are fall down to the below the user defined limit is, one is chunk server become unavailable, in the sense because of network issues, because of hardware issues, because of software issues, whatever it may be the issue. If the system is not working properly, then the replica information is not available, right? And it may be corrupted data in a chunk. So some part of your data may be corrupted due to some problems, virus or etc. 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 Okay, so if it is not correct, what happens in that case? Those kind of chunks are called as orphan chunks. Those are corrupted or partially corrupted or partially not correct. So such kind of chunks are called as orphaned chunks. Okay, and disk errors and increased replication limit. So these are all the various factors. Because of these factors, your number of replicas are fall down to the below the user defined limit. So whatever it may be the reason, always the system has to, Google file system has to maintain the number of replicas which are defined by the user. Okay, if you are not defining anything, by default how many copies are maintained? Only 3. Okay, so 3 are enough for actually, but depends upon your requirement. Either you may increase that replication or you can decrease that. You can do it with the configuration files. And next, rebalancing is done periodically by master, right? So after creating the new replicas, okay, immediately you need to rebalance the entire thing, because you need not maintain the information regarding the previous allocation process. Previously, you have allocated to 5 systems. Out of 5, 3 of them are not working. So because of that reason, you have created another 3 more copies, and those 3 copies will be stored somewhere. So now what you are supposed to maintain? Whatever the 2 previously not modified content information plus 3 newly created information. Yeah, so master has to maintain the information regarding these 5 only. So that is the reason what it has to do. It need to be updated. It need to be recreate the entire the mapping process. Okay, so that rebalancing should be done periodically. Master examines the current replica distribution and moves replicas to even disk space usage. Right? So in such a way, it is going to perform. And next, gradual nature avoids swarming of chunk servers. Okay, so the rebalancing also need to be done whenever if you modify the number of replicas that are to be available, right? So this is about replication and rebalancing. A garbage collection. Garbage collection, we can in GFS we can call it as a lazy, because the update master log immediately but do not reclaim the resources for a bit. It takes some time to reclaim the resources. So there should be a certain gap. So that is the reason why we are calling it as a lazy. A chunk is first renamed, not removed. Okay. So whenever if you are modified it, it is going to be renamed, but it was not the previous version is not removed from it. So that is in such a way it is going to be work. Periodic scans removes renamed chunks more than a few days older user defined. Okay, garbage collection. What do you mean by garbage collection? This just simply it collects all the unnecessary information or unused information which is available, right? So orphan chunks, as we have discussed it, partially modified data. And now fault tolerance. This is also another important factor that you are supposed to know regarding a Google file system. So first point is fast recovery. Whenever if a fault is occurred, whenever a correct, if your system is crashed, what we are supposed to do, that is what we are calling it as a fault tolerance. So first point is fast recovery. So that means within no time you are able to restore and restart the operations, even though it is master or chunk servers. Right? Next one is chunk and replication. Each chunk is replicated on multiple chunk servers on different racks. As I told you, the replicas are stored at remote systems. Remote systems in the sense, don't think that they are at rural areas. Don't think that they are at rural areas. Here our intention is remote place in the sense we are going to be distributed into different systems where the systems which holds the replicas may not be in the same cluster or may not be in the same region. So for example, in our case, you can assume that remote location means maybe one replica may be stored in US and another replica may be stored in France and another replica may be stored in India. In such a way, you can assume that. Okay. All right. And according to user demand, the replication factor can be modified for reliability, as we have discussed already. Master replication. Okay. Operations law. One is the master has to maintain the information regarding the historical record of critical metadata changes, as we have discussed in the last class. Okay. It maintains the changes of metadata will be updated at the master node itself. And operation log is also be replicated on multiple machines, because whenever if a system master gets failed, we are supposed to be restore the previous data. For that purpose, we did this operation log, and these two operation log is going to be replicated at multiple machines. Right now, let us come to the conclusion of GFS. What we understood from the past discussion is GFS is a distributed file system that supports large-scale data processing workloads on commodity hardware. So you are able to process the large volume of data using the cheap hardwares, right? And that is the first advantage of GFS. The second one is GFS has different points in the design space. One is component failure as the normal. As the normal, it is not an exception. It is quite natural. There might be a possibility of failure of systems. Okay. So keep it that point in their brain. They were defined the GFS and optimized for huge files, which will be best suited for only huge volume of data. If the file size is very small, say for example, if it is in KBs, this system will not give you your expected performance. And GFS provides fault tolerance, right? How it provides the fault tolerance in the sense it maintains the replicas of the data, okay, and fast and automatic recovery, because all the information is replicated and it was stored at different machines. So that is the reason whenever if it gets failed, immediately we are able to we are able to restore it and we can restart the operations. GFS has simple centralized master that does not become a bottleneck. So it will not become any headache, because just simply it distributes the tasks to each and everyone. It will not perform anything. Just it distributes the tasks to all the chunk servers, and just it is only supervisors. So that is the reason it does not become a bottleneck. GFS is successful file system, an important tool that enables to continue to innovate on Google's idea. So this is what about Google file system and the operations of Google file system and advantages and disadvantages. Hope you are all clear with this, because this will have the Hadoop is developed, designed and developed by using this procedure or whatever the mechanism that Google has followed. With the same mechanism, they were developed Hadoop. But Google file system is meant for Google only, whereas Hadoop is going to address or it is going to solve various general purpose problems also. Right? Hope you all clear in this. And if you have any queries, you can ask. Otherwise, we'll move to the discussion of Hadoop and HDFS. Hadoop and HDFS. Any queries? Because one should clear with this GFS. That is the reason why I'm asking. If you clear with this, you can easily understand Hadoop and HDFS concepts. So that is the reason. Any queries? If you have any query, you can unmute and you can ask. I was allowed to you to unmute yourself. You can unmute and you can ask. Otherwise, I'll discuss the Hadoop distributed file system. Can we change the address of the created object? Created object in the sense already stored one, right? Somebody is asking a question like, sir, can we change the address of the created object? Created object in the sense, whatever the application that you have created, can we modify it or not? That is your question or not? You don't have, nothing is there in your hands. Nothing is there in your hands. Only address in the sense, always the entire storing process or keeping your information into various systems will be taken care by master. It won't allow you to do anything with your own. You cannot instruct the master to store your information in so and so system, or you store the information in so and so. You cannot instruct in such a way. Just only you just pass the information to it. It will take care of. It will have a mechanism how to balance it, and what way it is supposed to assign to the various chunk servers and all. So that is the reason you cannot change the address. Address in the sense, okay, you can post that question. You can post that question. I'll answer it. Okay. Yeah. Anybody else? Okay, you can post that question to me so that I'll discuss in the subsequent sessions. Right. So now, let us talk about Hadoop and Hadoop distributed file system. Is it visible to everyone? Is it visible or not? Okay. Right. Now, let us talk about Hadoop, which is developed by Apache Corporation. So now, what is a Apache Hadoop? It is an open source software framework designed for storing and processing of huge volume of data on clusters of commodity hardware, same as Google file system, same as Google file system. Okay, clusters of commodity hardware. So here also our major intention is we are able to process the huge volume of data without compromising the efficiency. Okay, and initially it was created by the two gentlemen, Doug Cutting and Mike Carfella, in 2005. Okay, the Cutting named the program this particular project name as Hadoop is after his son's toy elephant. After viewing his son's toy elephant, by using this toy, he is going to suggest the name as Hadoop. This is the name of the toy which is used by Mr. Cutting's son. So that is the reason he put the name as Hadoop. Right? So what are the uses of Hadoop? So what we can do with Hadoop is the data intensive text processing, assembly of large genomes in the sense which is also used to process the genes, bioinformatics. You might have heard about the domain bioinformatics, where we can study about all the these genes and DNA, RNA, mRNA, the sequences. Well, let us think about in today's COVID-19 situation. You might have observed that the genome is changed its behavior in 56 ways. Like that, we studied some some news articles in papers and as well as in the reputed journals. So this will big data. I mean, Hadoop will also use it to analyze those data also for the prediction of the changes in the genomes also. And graph mining, machine learning and data mining, large scale and social network analysis like Facebook, Twitter and all. These all are uses this particular Hadoop framework. So what is the reason behind because of the reason it is able to process huge volume of data. Okay, it can store and process huge volume of data, and it works with the commodity cheap computer systems. We are able to process this huge volume of data with the available cheap computer systems only. You need not purchase a costly, highly configured systems for keeping and processing of your data. Okay, so that is the reason all these areas where we are using this particular Hadoop. Right? So these are some of the organizations which they are using the Hadoop for their analyzation process. Not only this, there are so many organizations are there. Just for better understanding, because you know about the most popular companies, that is the reason I will mention only these names. Right? There are n number of companies are using this Hadoop right now. So what Hadoop ecosystem contains is, so first part is Hadoop Common. Just it contains, I'll show you the diagram in the later slides, what way the ecosystem is defined, what are the names of the tools that are meant for all these four purposes. So first one is Hadoop Common, which contains the libraries and other modules. So it acts as an interface for the other programming language. By using those languages, whatever the way you are going to implement the big data applications, because it is not only restricted to Java. You can use Python or programming. There's any kind of programming language that's for the implementation of your big data applications. Okay. And next one is Hadoop distributed file system. This is a core component of the Hadoop ecosystem, which just like it is you just imagine that it is just like a file system in your computer. Okay, in our computer we may find C drive, D drive, E drive, where we can store the various directories. In that we'll store a number of files. Okay, so which is similar to that. Okay, just it is a storage area where you can keep storage. In the sense, don't assume that it is a data center or it is something else, right? It maintains a mechanism Just like Google file system, what way it is going to maintain the data by using master node and chunk servers, here also it will perform the same. By using name node and data nodes, it is going to maintain the information at irrespective of the size of the file which you have supplied as an input, and that can be, you are able to retrieve, you are able to store, you can do certain operations on it also, right? So these all things will be dealt with the HDFS. And Hadoop YARN, YARN stands for yet another resource negotiator. Okay, so this is the component which is going to be communicated with all the resources for the continuation of the process one after another. Okay, so and Hadoop MapReduce, it is a programming model for large scale data processing. So here you need not worry about how to store the data, how to retrieve the data, these all things. Just you are supposed to focus on how to define a mapper method and how to define the reducer method. Only two methods you are requested to implement. With that, you are able to analyze whatever it may be the size of the data that on which you are going to perform the analyzation part. That means the programmer need not worry about how to store, how to retrieve the data. Just simply with the simple commands, you are able to store and you are able to retrieve the data from HDFS. So only thing you are supposed to focus is what kind of analysis you required, what way you are supposed to implement. That is only the thing which you required. Okay. So these are the Hadoop ecosystem components. Now, what are the things that are motivated for us for implementing the Hadoop? So the first reason is Google file system is meant for, because it was developed in the year 2003, whereas it was developed in the year, it was started development in the 2005 only. Okay. So the first motivation is Google is, it's a proprietary distributed file system, whereas this Hadoop is open source framework. That means it is open to all, everybody can use it and they can solve their problems by using this particular one. That is the first one. And another one is what are the limitations of earlier large scale computing? What happens, what we did in the previous, before inventing these two, what we did with the large scale of data, what way we can store it, what way we can process it. That is the one of the major motivation for the development of Hadoop. And another one is what requirements should an alternative approach have? So whatever the process that exists before invention of GFS and HDFS, okay, not only HDFS, Hadoop. Okay, so what are the other options? Because by keeping that point in brain, they have developed this mechanism. So how does this Hadoop is address those requirements? Okay, so these are the three important factors that motivate us for development of Hadoop. Now let us look at about these 3 points. So first one is early large scale computing. What we did in the previous cases before existing of GFS is historical computation was processor bound. There we will depend on processor. Always we will try to increase the processor capacity to process the data. Okay, so the data volume has been relatively small when compared to the today's scenario, because in the Facebook itself today's scenario, it generates 500 terabytes of data per day. Similarly, Twitter and all the social media. So you can imagine, similarly, in the first class, we have discussed about American Stock Exchange. Like there are several places where the huge volume of data is going to be generated on every day. But before that, there is no very limited amount of the organizations which are generating that much of data before inventing these two mechanisms, right? So they forecasted, they predicted it. In future, definitely there are a number of organizations, they are going to be generated huge volume of data. So what way we can accommodate it, what way we can process it. So these things, they are going to be analyzed well in advance, and they have developed this mechanism, right? And advances in computer technology has historically centered around improving the power of a single machine. So there we have started improvement because data centers, okay, servers, highly configured servers, supercomputers, okay, these are all the advancements in the technologies through which we can process that data. Now coming to the distributed systems, in the distributed systems allows developers to use multiple machines for a single task. Okay, So here we will distribute the task to the n number of systems, and all the 10 number of systems are trying to produce the output for our task. So you can imagine these are the racks you can observe in our labs. Okay, these are all the servers. Different servers are maintained in the different racks. And let us try to understand what are the problems that exist with the distributed file system. Okay, programming on distributed system is much more complex because synchronizing the data exchanges, because the data is processed at a different systems. So synchronizing one may complete it too early, one may take a lot of time to process it. So we need to be synchronize all these things of the data exchanges between one system and the other system where the same task is available. Okay, and managing a finite bandwidth, as I told you, bandwidth here, what way we can understand is just movement of data from one place to another place. So while transmit, because not all the systems are maintaining the same bandwidth, because you may maintain high bandwidth, I may maintain low bandwidth. Okay, in that case, how to manage? Because if somewhere it is high, somewhere it is low, it leads to the performance issue. So that is the reason, how do we manage without compromising the performance? Okay, so that is also an important aspect. And controlling computation timing is complicated, right? So as we have discussed, the timing factor, one may complete it first, one may complete it last. So how do we control all these things? Okay, so and another important point is, here you can observe the code. You know, you have a distributed system. When the crash of a computer, you have a distributed system. When the crash of a computer, you have never heard of stops you from getting any work done. Okay, so this is the important quote regarding distributed systems given by the Lamport. Okay, so here what happens is, even though it is going to be crash, whatever the work that you have done, that you are able to restore it, you are able to get it back within no time. Okay, and distributed systems must be designed with the expectation of failure. As I told you, with the expectation of failure, always you can assume that the distributed system, the systems which are present in the distributed system are failed. Even all the systems are failed also, you are able to restore it within no time. So that is our target. Now, so distributed system data storage, where can we keep that information? What way we can store the data by using distributed systems is typically divided into data nodes and compute nodes. Okay, it will be divided into two nodes. One is data node and another one is compute. At compute time, the data is occupied to the compute nodes. Initially, we have transferred to the compute node, and then it will be shifted to the data nodes. Very soon we will discuss in detail about these two also. Fine for relatively small amounts of data. As I told you, GFS is meant for only handling the large volume of data, because Google is going to handle always a huge volume of data. So that is the reason they have developed a mechanism for their own purpose. But here it is a general purpose mechanism. So that is the reason it is relatively small amounts of data also, it is a little bit okay. It's fine. So modern system deal with the far more data than was gathering in the past, right? So whatever the data that we have previously, but today's scenario, we will collect more than that, and we can process a huge volume of data. All right. So this is the sum of the facts regarding how much of data is going to be generated in a day. Okay. Facebook is going to generate 500 terabytes of data. Yahoo or 170 petabytes. eBay or like that. There are so many places. Not only this. There are so many places where we can observe a huge volume of data is going to be generated in a day. Getting the data to the processor becomes the bottleneck, right? Getting the these all the information, whatever the information that is acquired, that was generated in a day, will be processed. So we need to be define a good mechanism to handle it. Okay. So now let us talk about what are the requirements for the Hadoop. You must support partial failure. So the Hadoop system goal is it must support the partial failure. It must be scalable. Scalable in the sense whenever if you are adding number of systems to your clusters, the performance should be the same. That means it won't be affected even though if you add a number of systems. In the similar way, if you add a number of tasks, in such case also with the same cluster, you are able to produce the same performance. So even though the network is grown up, the performance should not be compromised. So partial failures means the failures of a single component must not cause the failure of the entire system. Okay. So even though it was failure, yes, you just keep it in a way and you can start doing the operations with some other system, and within no time, that means whatever the time it is required to process, okay, before failure, you are supposed to process in the same way even though after the failure has occurred. Okay. And failure should not result in the loss of any data. Okay. So whatever the system which is failed, which can keep some information, okay, that may not be a single source of the data. So that is the reason. As anyway, here it also will maintain 3 replicas. There is no possibility of failure of data loss. So component recovery. If a component fails, it should be able to recover without restarting the entire system. Just simply we exchange the task. That's it. We need not worry about the entire system is going to be restarted, right? And component failure or recovery during the job must not affect the final output, as I told you. Okay, whatever the performance that we are expected, it should be the same after the failure also, after the failure has occurred also. Okay, the scalability. Okay, scalability in the sense increasing the load or increasing the number of nodes in the system also. So this is some information regarding what Google file system and what way the Hadoop is going to, I mean, in which year the Hadoop implementation is going to be started. Okay, this we have discussed already. The core idea was to distribute the data as it is initially stored. Okay, each node can then perform computation on the data it stores without moving the data for the initial processing. We'll see in detail about all these things. The core Hadoop concepts are applications are written in high-level programming languages, right? So here what happens is, in the previous semester we studied computer networks. There we have developed several programs through which we can communicate to the server. That means we can pass the information to the server and we can get it, a response from it, right? Like that we have developed some programs. So here you need not write any network programming to transfer the data from one place to another place, right? Even though it is large in size. So in such a way, it allows the high-level programming languages to develop the code and it could be executed. A node should be communicated as little as possible, right? So there is no interdependency that exists among the nodes. Like as a Google file system, there is no way we have discussed about the coordination between one chunk server and another chunk server. Always we are talking about the coordination between master and the chunk server only. So in the similar case here also, there is very few communications that exist among the one data node and another data node. Okay, because it follows the share nothing to be shared with the data nodes. Only the information is shared between master and the chunk server. In the case of GFS, here only name node and data node. Okay, so data is spread among the machines in advance. Okay, so perform computation where the data is already stored as often it is possible. So these things, fault tolerance also here, the similar kind of fault tolerance which is maintained by the GFS. So once again we'll look at it. Failures are detected by the master program, which reassigns the work to a different node, right? There also we understood master, that means the key component which will take care of reassigns the responsibilities to the other chunk servers if one chunk server get failed. Here also the same. Restarting a task does not affect the nodes working on the other portions of the data. As I told you, whenever if a particular chunk server is failed, immediately the master will look for the second replicas of the data which is available with the server one. Okay, whatever the data that was stored in the server one, okay, the same data where it is present in the other machine will be found by the master, and immediately it alerts that particular chunk server to start the execution. But probably that particular server may be engaged with some other work. Okay, still in that case also, without disturbing that task, you are able to complete it, right? Because balancing, whenever if it is busy, it look for the other system where it is free. Okay, in such a way, it is going to be balanced, and without disturbing the current executing tasks, it is able to process the new tasks also. If a failed node restarts, it is added back to the system and assigned new tasks. Okay, whenever the basic assumption of the distributed system itself is there is a failure. Okay, after restarts it, so immediately it passes information to the master like now I am active. It passes a heartbeat to the master whenever it conducts the poll. So what happens in that case? Again, it creates, it stores the information regarding the chunk server and it will be allocated. In the similar way here also, here we are not using the words master and chunk server. In the place of master, we will use the name node. In the place of chunk servers, we will use the name data nodes. That is only the difference. But functionality is almost similar. And the master can redundantly execute the same task to avoid slow running nodes. So execute the same task to avoid the slow running nodes. So it depends upon the performance of that nodes. It is going to be. Now, so in the next class, we will start the Hadoop distributed file system. Okay. Until then, we have discussed the basics of Hadoop. Okay. Right. We will discuss the remaining part in the next class. Now, you can unmute yourself. Jayprakash, mute off your video. So today's absents are A3, D0, D4, D7, E1, E5, E7, G2, H2, H4, H5, H7, I2, I8, sorry, I2 and LE503. So these are the absentees for the today's class. So many people are absent for today's class. Right, any queries? You can unmute yourself and you can ask. Any queries? Anybody? Are you there or not? Almost 71 people are present in the class. You have any queries? No issues? All right. And a small announcement regarding the supply examinations, that is 2131 and 11. We have already placed the notifications like the fees amounts and what way you can pay. That means the account number and all we have shared with you in WhatsApp groups. So you please go through it, and you just, if you want to write any supply exams, you can pay the fees, and those receipts should be submitted to your counselor so that they will submit it to the class teachers. Right? Hope you all clear with this. Even I have shared the wrapper classes information to your group also. You can, unit 1 material was shared with you. So you please go through it. Any queries? No issues? Okay. I'll end the session now. You may leave. Thank you.